Imagine two gardeners. Same neighborhood, same climate, same amount of sunlight hitting their backyards every single day. The first gardener spends the entire spring testing, amending, and enriching her soil. She buys bags of compost, bottles of liquid fertilizer, and expensive raised bed mixes. She plants her seeds carefully, waters consistently, and by July, half of what she planted has withered, yellowed, and died. The second gardener does something different. Something that looks almost reckless. She looks at her hard, gray, compacted soil, the kind that cracks like pavement in summer. And instead of trying to fix it, she asks one simple question. What already wants to grow here? She plants accordingly. No amendments. No fertilizer. No expensive soil mix. And by July, her garden is absolutely thriving. Now here's the question that should be sitting uncomfortably in your mind right now. What did that second gardener know that the first one didn't? The answer is sitting in 14 plants. Plants that have been quietly surviving in the worst soils on Earth for thousands of years, in rocky hillsides across Europe, in the dry compacted plains of North America, in the clay-heavy landscapes of the United Kingdom, waiting for gardeners like you to finally notice them. Stay with me, because what I'm about to share completely changes the conversation around bad soil, and around what your garden is actually capable of. Welcome to Evergreen Garden Life. If you are new here, please take a second right now and hit that like button, share this video with a fellow gardener who needs to hear this, and subscribe to the channel. Let's start by addressing something that the gardening world has been getting wrong for a long time. When most people hear the words bad soil, they immediately go into panic mode. They think they are dead, useless, beyond saving. And so they do what every garden center, every well-meaning neighbor, and every generic YouTube video tells them to do. They try to fix it. They amend it. They till it. They dump bags of material into it. They spend money they didn't need to spend, time they didn't have to waste, and energy they could have directed somewhere far more productive. But here is the truth that changes everything. Bad soil is not one thing. It is not this single, simple problem with a single, simple solution. Bad soil actually comes in three very distinct forms, and each one behaves differently, challenges your plants differently, and requires a completely different approach. And once you understand the difference, you stop panicking, and you start making smarter decisions. The first type is compacted, clay-heavy soil. This is the dense, suffocating soil that you find in older gardens, in lawns that have seen heavy foot traffic, and in many suburban backyards across the United Kingdom and the northeastern United States. Clay soil packs tightly together, which means oxygen struggles to move through it. Water pools on the surface instead of draining properly, and roots, most roots, simply cannot push through it. It feels like trying to grow a garden in concrete. The second type is nutrient-depleted, sandy soil. This is the opposite extreme. Sandy soil drains so fast that water and nutrients are gone before roots even get a chance to absorb them. You find this type heavily across the southern coastal regions of the United States, parts of Australia, and in many areas across southern Europe. Plants planted here often look stunted, pale, and weak, not because they are diseased, but because the soil has nothing left to give them. The third type is chemically imbalanced soil. This is where the pH, the measure of how acidic or alkaline your soil is, sits so far outside the normal range that plants physically cannot absorb the nutrients that are right there in the ground. The nutrients exist, but the chemistry of the soil locks them away like food behind a locked door. And this happens more often than most gardeners realize, particularly in areas where industrial activity, heavy rainfall, or years of synthetic fertilizer use have shifted the soil's natural balance. Now here is why understanding these three types matters before we get to our 14 plants. Because the plants we are about to talk about did not just randomly develop toughness. Each one evolved in response to a specific kind of difficult soil. Their roots, their chemistry, their entire biological makeup was shaped by the exact challenges we just described. And that means when you know your soil type, you can choose the right plant with precision, not guesswork. Here is something that blew researchers away when they started studying how these plants actually survive. According to a foundational study published by Nature Education, one of the most universal adaptations to nutrient-limited soils is a direct change in root structure. where plants increase the overall surface area of their roots or elongate their root systems to access nutrients that other plants simply cannot reach. Think about that for a moment. While most plants are dying because they cannot find food, these plants are literally rebuilding their own root systems underground, stretching, branching, and pushing deeper to find what they need. They do not wait for conditions to improve. They adapt to the conditions in front of them. And it goes even deeper than that. Many of these resilient plants form what scientists call mycorrhizal relationships, a word that sounds complicated, but describes something remarkably elegant. Essentially, certain plants form partnerships with underground fungi. The fungi extend tiny thread-like structures called hyphae deep into soil pores that are far too small for any root to enter. Through these threads, the plant accesses phosphorus, zinc, copper, and other minerals that would otherwise be completely unreachable. And according to Biology Libre texts, drawing from OpenStack's General Biology, this beneficial relationship is most powerful and most active in poor soils. In other words, the worse the soil, the harder this underground partnership works. Nature literally designed these plants to thrive in the conditions that would destroy anything else. Now, before we get into the plants themselves, there is one more thing I need to address, and this might be the most important thing in this entire video. It is the mistake that even experienced gardeners make, and it is the reason many of these resilient plants fail even when they are supposed to succeed. The mistake is this: over-amending your soil before planting species that were never meant to grow in rich soil. It sounds generous. It sounds responsible. But for many of the plants on this list, adding heavy compost, rich fertilizer, or nutrient-dense soil mixes before planting is like handing a marathon runner a 5-course meal right before the race. It does not help them. It slows them down. It changes the conditions they were built for, and in many cases, it kills them outright. Lavender is a perfect example. Its drought tolerance and preference for nutrient-poor soil is precisely why it thrives where other plants fail. And excessive moisture or over-rich soil leads directly to root rot. These plants do not need your help to survive in bad soil. They need you to trust the process and get out of their way. Remember that as we go through the list. So now, let's talk about the 14 plants. And I want you to pay attention not just to the names, but to why each one works, because that understanding is what will make you a genuinely better gardener. Starting with number 1, Black-Eyed Susan, known scientifically as Rudbeckia hirta. This is one of the most underestimated plants in North American gardening. It is native to the open prairies and roadsides of the United States, which immediately tells you everything you need to know about its soil preferences. It evolved on land that nobody was fertilizing, nobody was watering, and nobody was nurturing. Its root system spreads fibrous and wide, maximizing surface contact in sandy or depleted soils, and it blooms gloriously even when the ground beneath it is practically empty of nutrients. What makes Black-Eyed Susan particularly special is that it does not simply tolerate bad soil. It looks genuinely spectacular in it. Bright golden yellow flowers on strong upright stems, season after season, with almost no intervention required. Number 2 is purple coneflower, Echinacea purpurea. If there is one plant that embodies the spirit of this entire video, it is this one. Echinacea is a deep taproot plant, which means its root drives straight down through compacted layers, through clay, through rocky ground, to reach moisture and nutrients that shallow-rooted plants could never access. It tolerates drought, it handles heat, and it manages clay and sandy soil with equal ease. Beyond its toughness, it is a powerful pollinator magnet. Bees, butterflies, and birds are drawn to it consistently, which means planting it actually begins to bring life back into a garden that may have felt dead for years. Number 3 is butterfly weed, Asclepias tuberosa. This is a plant with one of the most impressive root systems in the entire botanical world for its size. Its long, thick taproot drives deep into poor soil and acts almost like an anchor, giving the plant access to water and nutrients far below the surface during droughts. It grows natively across the United States in sandy, rocky, and clay-heavy soils, and it produces clusters of vivid orange flowers that make it one of the most visually striking plants you can add to a difficult garden. It is also a critical host plant for monarch butterflies, so planting it carries ecological weight beyond just aesthetics. Number 4 is yarrow, Achillea millefolium. Yarrow has been growing in the poorest soils across Europe and North America for centuries, and there is a reason it keeps showing up in the hardest, most neglected corners of landscapes. Its feathery foliage and flat-topped flower clusters look delicate, but this plant is anything but. Yarrow's root system is fibrous and aggressive, spreading through compacted and nutrient-poor ground with ease. It handles clay, handles sand, handles drought, and handles neglect, and it still produces flowers reliably year after year. In parts of the United Kingdom, it grows wild along roadsides and in fields that have never seen a bag of fertilizer. Number 5 is sedum, also called stonecrop, Sedum spectabile. The name says everything. Stone. Crop. This plant grows in the kind of ground where stones outnumber soil particles. Its ability to store water directly in its thick, fleshy leaves means it carries its own reserves through droughts and nutrient-deficient periods. It thrives in poor, gravelly and sandy soils and tolerates clay as long as the ground does not stay constantly waterlogged. Sedum is also one of the most architecturally beautiful plants on this list. Its rosette-shaped foliage and late-season blooms make it a standout in rock gardens and border fronts across the United States and Europe. Number 6 is lupin, Lupinus perennis. And this is where things get genuinely exciting, because lupin is not just a plant that survives bad soil. It is a plant that actively works to fix it. Lupins are nitrogen-fixing plants, which means they pull nitrogen directly out of the atmosphere and convert it into a form that the soil can use. They do not need nutrient-rich soil because they produce their own nutrients. And over time, as their biomass breaks down, they leave the soil measurably more fertile than when they arrived. According to Epic Gardening, lupin can fix comparable amounts of nitrogen per acre to clover and hairy vetch, two of the most respected soil-building cover crops in agriculture. Plant lupins in your worst soil today, and in 2 to 3 seasons, that same soil will be dramatically better. That is not gardening. That is long-term soil investment. Number 7 is ironweed, Vernonia fasciculata. This towering perennial is one of the least talked about plants in the gardening space, which is a genuine shame. Ironweed develops deep, stabilizing roots that help break through and anchor in both clay and rocky ground. It accesses nutrients in harsh, compacted conditions through root depth and architecture that most ornamental plants simply do not possess. Its deep purple flower clusters are visually dramatic and bloom late in the season when most other plants have finished, extending the life and color of your garden well into autumn. Number 8 is blue star, Amsonia species. Research published in horticultural literature confirms that blue star develops deep taproots that make it a long-lived, exceptionally durable plant once established, and it handles chalky, clay, sandy, or loamy soil across a remarkable range of growing zones, from USDA Zone 3 all the way to Zone 11. That kind of adaptability is rare. It produces soft blue star-shaped flowers in spring, and its foliage turns a brilliant golden yellow in autumn, giving it 2 distinct seasons of visual interest. In the United States, it grows across the Southwest Desert and the Southern Plains, 2 of the most soil-challenging regions on the continent. Number 9 is Baptisia, commonly known as wild indigo, Baptisia australis. This is a nitrogen-fixing native perennial that has been growing in the poor, rocky soils of the eastern United States for thousands of years. Like lupin, it forms relationships with soil bacteria that allow it to convert atmospheric nitrogen into soil-available nutrients. Its deep root system makes it drought-resistant and structurally self-sufficient, and once it establishes, typically in its 2nd or 3rd year, it becomes virtually indestructible. It produces beautiful blue-purple pea-like flowers in late spring, and its seed pods rattle dramatically in autumn winds, adding texture and sound to the garden. Number 10 is Gaillardia, commonly called blanket flower, Gaillardia aristata. According to Southern Living Plants, Gaillardia not only thrives on poor sandy sites, it also performs well in soils ranging from acidic to alkaline, meaning it handles 2 of our 3 bad soil categories simultaneously. This is an exceptional quality. Its vibrant red and yellow daisy-like blooms are drought-resistant and long-lasting, and it requires very little maintenance once planted. Across the southern United States, where sandy and chemically imbalanced soils are common challenges, Gaillardia shows up reliably and colorfully where almost nothing else will. Number 11 is comfrey, Symphytum officinale. Comfrey is one of the most functional plants on this entire list. Its taproot can penetrate 2 meters or deeper into compacted subsoil, breaking up hardpan layers that would stop other roots entirely. As those deep roots grow and eventually die back, they create channels in the soil, pathways that allow air, water, and other roots to follow. Comfrey's large leaves also accumulate nutrients drawn from deep in the soil, and when those leaves die back seasonally, they deposit those nutrients on the soil surface as natural mulch. It is simultaneously a soil breaker, a nutrient miner, and a surface fertilizer, all in one plant. Number 12 is buckwheat, Phagopyrum esculentum. According to hobby farms, buckwheat produces root exudates, chemical compounds released from its roots, that actively improve the soil's biological diversity and enhance phosphorus availability in the ground. Phosphorus is one of the nutrients most commonly locked away in chemically imbalanced soil, and buckwheat essentially unlocks it. It grows fast, covers ground quickly, suppresses weeds, and when cut back and left on the surface, adds organic matter that improves soil texture over time. In the United States and across parts of Europe, it is increasingly used as a fast-acting soil rehabilitation crop between main growing seasons. Number 13 is cowpea, Vigna unguiculata. Cowpea is exceptionally heat and drought tolerant, built for the harshest summer conditions that leave most gardens struggling. It is a nitrogen-fixing legume, meaning like lupin and baptisia, it actively returns fertility to depleted soil as it grows. According to hobby farms, cowpea can be used as a living mulch due to its tolerance of partial shade conditions, meaning it protects the soil surface from erosion and moisture loss while simultaneously rebuilding its nutrient content. In the deep southern United States, where summer heat and sandy, depleted soils are a year-round challenge, cowpea has been a trusted soil companion for generations. Number 14 is river birch, Betula nigra. We close this list with a tree, and there is a very deliberate reason for that. Because sometimes the solution to dead, compacted soil is not a flower or a herb. Sometimes it is something with the structural power to fundamentally change the ground it grows in. River birch grows best in acidic, moist soils but demonstrates a remarkable ability to adapt to the yearly fluctuation between wet soil in spring and dry, compacted soil in summer. According to the Missouri Botanical Garden, it also tolerates the difficult urban conditions of compacted soil and air pollution, making it one of the most resilient trees available to gardeners across the United Kingdom and the northeastern United States who are dealing with dense, heavy, neglected ground. Its root system is expansive and powerful, and over years, it physically loosens and aerates the compacted soil around it. Now here is the thing I want you to sit with for a moment before this video ends. Every single one of these 14 plants exists because bad soil exists. They did not develop their remarkable root systems, their nitrogen-fixing abilities, their deep taproots and mycorrhizal partnerships in spite of difficult conditions. They developed them because of difficult conditions. Over thousands of years of evolution, these plants looked at the worst possible growing environments: the compacted clay hillsides of Europe, the nutrient-stripped sandy plains of North America, the chemically challenging soils of landscapes that had been neglected for decades. And they said, we will grow here anyway. And if you are sitting in a garden right now that feels beyond saving, I need you to hear this. You do not have a bad garden. You have a garden that has not yet been introduced to the right plants. Stop over-amending. Stop overspending. Stop blaming your soil. Start selecting with intention. Start working with what nature already built. And start watching what happens when you give these 14 plants the one thing they have always been able to handle: the honest, unimproved ground beneath your feet. If this video gave you even one new insight about your garden, please do not keep it to yourself. Share it with someone who needs it. Hit the subscribe button right now. It genuinely helps this channel reach more gardeners who are struggling with exactly this problem.